Hey, third graders, welcome back. We're going to do our math lesson today, and I want you to turn in your math journal to page 317. Okay, so pause the video and find that page. You'll notice that I have my number path whiteboard. So you're going to need to find that. We talked about that the other day. This is going to be a really great way for you to use for area and perimeter because the back, right, has that centimeter dot paper, and we're going to be using that today and a little bit in the future. So let's take a peek at what we're supposed to do, and then we're going to do some drawing on this whiteboard. If you can't find yours, you're going to have to just follow along. See if you can locate it. Everyone was given one. And I'm going to do some drawing on mine. If you have yours, and you'll be able to just copy down what I'm doing. It's a very visual activity, so you're going to really need to look and be able to compare some things. So we're going to talk today about two different things. We're going to compare rectangles that have the same perimeter, okay, so the area around the outside. And then on the page on the back, we're going to compare rectangles, but instead of the same perimeter, they're going to have the same area on the inside, okay? And we're going to talk about what that looks like and how do we figure that out. So let's read the directions first. Okay, it says on a centimeter dot grid, which is what this is, right? These dots are 1 centimeter apart. We have to find and draw all the rectangles we can that have a perimeter of 12 centimeters. And I want you to circle that, underline it, highlight it. The perimeter is around the outside, right? You've learned that this week. So that's not anything we need to talk about. Perimeter goes around the outside like a fence would line someone's yard, right? So what we're going to do is we're going to find all the different shapes that have a perimeter of 12, all right? And we're going to compare and see what they look like, see what the area is on the inside, and then make an observation down here for number 3. We're going to do the same exact thing at the bottom, and then on the back, like I said, we're going to switch. Instead of having the same perimeter, we're going to see about having shapes with the same area on the inside. Okay, so if it's got a perimeter of 12, then I know all 4 sides have to add up to 12, right? We've had some shapes where you'll see on your homework, it might look like this, right? And if I were to count the perimeter, 1, 2, 3, 4, and on the other side length, 1, 2, 3, 4, 5. Right? Sometimes they only give you 2 side lengths, but you're smart and you know that the opposite sides of a rectangle are exactly the same. So you know this side would be 5, you know this side would be 4. These 2 side lengths are called adjacent. That means they're next to each other. Okay, adjacent means next to. At the top of this page, I want you to write that definition. We're going to write the word adjacent. It's spelled kind of funny. Adjacent equals next to. Okay, and they're talking here about the adjacent sides of rectangles. Okay, so make sure you have that definition down. It's going to help us figure out how many different shapes we can draw that have the same exact perimeter. Okay, if I were to add these two numbers together, right, 5 and 4, that equals 9. So I know the other side's 9, right? So I know my perimeter would be 18. So I'm going to try to figure out if I need a perimeter of 12, right, what would be my side lengths? Right, if all 4 sides add up to 12, right, remember these 2 side lengths are just half of that, right? So what would these 2 sides need to add up to? If the whole thing has to add up to 12, then the adjacent sides, right, the sides that are next to each other, have to add up to half of that, right, to 6. So my adjacent sides need to equal 6. So I'm going to write that down here. Adjacent sides total 6 centimeters. Okay, so I'm going to think about what partners could I add together that would add up to 6? Well, why don't I just start with the number 1, right? If this side is 1, if I have 1 centimeter, 1 plus what gets me to 6? Well, it's 5, right? So here's 1, 2, 3, 4, and 5. So I have 5 centimeters. I can see those squares there. I'm going to finish my shape, right? So if this side is 1, then I know the opposite side is also 1. Okay, let's add those numbers up. 5 and 5 is 10. 1 more is 11. 1 more is 12. Look at that. All I had to do was figure out 2 sides, or half of my perimeter, and think about what partners make half of my perimeter. So 1 and 5 would make a shape that has a perimeter of 12. So let's write that like that. 1 centimeter and 5 centimeters. That's how I make my and sign. You can make yours however you want. You could write the word and if you want. So if I have a 1 centimeter and a 5 centimeter adjacent side lengths, right, I'm going to erase that so that we get used to just seeing the 2 side lengths. I know that has a perimeter of 12. But what's my area? I'm going to connect my dots to make my squares. Right, remember, to find area, I just multiply. So if I multiply 1 times 5, I'm just going to get 5. But remember, it's squares, so I have to add that label in there. Right? So these I have to add together and then double them because there's 4 sides, not just 2. But when I find the area, I multiply. Okay, so we started with the number 1. What if I have a partner that's a number 2? I'm going to draw 2 lines. Okay, what can I add to the number 2 to get 6? I hope you said 4. 1, 2, 3, 4. Right? 4 plus 2 is 6. If my other 2 sides also equal 6, then altogether that makes 12. And connect my dots to show my area. And when I find area, I multiply those side lengths. Okay? So for this shape, I have a 2 centimeter and a 4 centimeter. But when I multiply them, 4 times 2 or 2 times 4, that's 8 square centimeters. So even though these 2 shapes have the exact same perimeter, they have very different areas, right? So if I had a table that looked like this, right, I could have 12 people around it. If I had a table that looked like this, I could also have 12 people around it. They would be sitting right in a different configuration. 2 people on the end instead of 1 person on the end. Right? So we started with our partner of 1 and a partner of 2. Let's try one of our partners being 3. So you'll see that I connected my dots to have 3 hops. Remember, I'm not counting dots, I'm counting the spaces between. So 3 plus what is going to get me to 6? Well, that's the double. So 3 plus 3 more. I'm going to connect those to make my shape. And then I can fill in my lines to show my area. So my partners here are the same. Remember, when our factors are the same, we multiply together. That makes a square number, which is why this is the shape of a square. So here my partners are both 3 centimeters. But what's my area? 3 times 3. I could count those, and I would come up with 9 square centimeters. Okay, so when we're trying to find the same perimeter, this example was 12, the same perimeter, I just have to find partners for my adjacent sides because I know then I'm going to double it, right? So 6 on 2 sides, 6 on the other 2 sides makes 12, right? It's just a different combination of numbers or partners. Okay? All of these shapes have a perimeter of 12, but their areas are very different, right? So we've done number 1 and 2. Now let's look at number 3. We're going to compare the shapes. Okay, it says compare the shapes with the least area and the greatest area. So here's the least area, 5, and the greatest area of 9. So let's compare those two. We're not going to worry about this one in the middle. What do you notice? The least area is kind of long and skinny, isn't it? The greatest area makes a square. So very different shapes. Okay, so we're going to write that down. Remember, if you have your centimeter dot board, then you can draw right along with me and you can see that for yourself. Okay, let's write that answer down so that we can remember when we compared them. Okay, the rectangle with the least area, least being smallest, is long and skinny. Right? The rectangle with the greatest area is a square. And remember, you can always pause the video so that you can write this down. You don't have to keep up with me. Look, I ran out of space, but I can write it down here. Okay. If we were going to do this next one, we're going to skip it. Okay. If we were going to do this next one, we would have to find a perimeter of 22. So all of my adjacent side lengths would add up to half of that, right? So they would have to add up to 11. So partners that would add up to 11. You'd have to be thinking of numbers that you can add together that would add up to 11. Okay. So like I said earlier, we're going to go from now shapes that have the same perimeter to shapes that have the same area, so the same amount on the inside. We're going to compare those. Okay, you can always come back or pause the video to copy all of this down. And then we're going to flip to page 318 to finish our lesson for today. Remember, one of our key words is that word adjacent. That means next to. Okay, those are the side lengths. These are adjacent lines. Okay, so let's look on page 317, or 318, excuse me. Okay, it's asking us to do a little more drawing, but it's got some different directions. Okay, so on that centimeter dot grid, that same whiteboard that we have, we're going to draw all the rectangles we can that have an area of 12. Okay, think about what you know about area. How do we find the area? What do we do with those adjacent sides in a shape? How do we figure that out? We have to multiply them, right? So we have to think of all the partners we can multiply together that equal 12 because the area is on the inside, which is 12. I like to always start with the number 1. Okay? If I do 1 as one of my partners, think about what am I going to multiply? 1 times what to get 12 as my inside area? Hopefully you know that that's 12, right? Anything times itself. Okay, so if I draw 1 centimeter and 12 centimeters. Those are my adjacent sides, the ones that are next to each other. Okay, here's one space, 1 centimeter, and I'm going to draw 12. I'm going to do them in groups of 2, a little bit faster. 2, 4, 6, 8, 10, 12. I've also done this a lot longer, right? So I can see pretty good when I'm drawing. Okay. You might also notice these dots here at the top. I always like to do it in the middle of my board just because I feel like I have more space. But if you notice, in between each of these dots is 5 centimeters. Let me show you that. 1, 2, 3, 4, 5. Okay, so you know that right there, you've got a group of 5. Okay. I like to draw mine more in the center, but that's a really great resource for you to be able to use. So here's my 1, and here's my 12. I know when I multiply them together that my inside, right, is going to be 12 square centimeters because that's the area on the inside when I multiply. But what would my perimeter be? If I know the opposite sides are the same, right? Add these together. It's 13. And then double that. That means add another 13 to it. Ooh, my perimeter is 26 on that shape. Okay, my area is 12, but my perimeter is 26. So I'm going to write that. Perimeter is 26 centimeters, not square centimeters, because it's not on the inside of our shape. Okay. So if one of my partners I started with was 1, let's try 2. What do I multiply 2 times the unknown to get to 12? I'm going to draw that picture over here too. Here's my 2. 2 times what gets me to 12? 2 times 6, you're right. 2, 4, 6. Finish my shape. Right. Again, 12 square centimeters on the inside. Right. But around the outside, my perimeter is going to be different. 6 plus 2. Remember, I have to add my perimeter. 6 plus 2 is 8. So I'm going to double that. 8 plus 8 more. If you know your doubles, you know that that's 16. So this shape has a perimeter of 16, but it has, right, still has the area of 12. So different shapes, same on the inside, very different on the outside. So if I had a party and I had it shaped, my table was shaped like this, I could fit 26 people around the outside of my table. But if I had a party and my table was shaped like this, I could only have 16 people at my party. Right? There were 10 less people because my table is just a different shape. Okay, let's try one more. We did partners, factors of 2 and 6. What can I multiply times 3 that's going to get me an area of 12? 3 times what equals 12? Do your count bys. We should come up with 4. 3 times 4 equals 12. So let me draw a 3 by 4 shape. There it is. My side lengths, my adjacent sides, 3 and 4. So I know the inside is 12 square centimeters, but not my perimeter. My perimeter, I have to add 4 and 3 is 7. And I know that the opposite sides are going to be the same. So I'm going to double that. And I know that the double of that is 14. So I've got an area of 12, but I have a perimeter of 14 centimeters. Okay, so remember, area, we multiply those factors together, right? So I'm looking for partners that I can add or multiply together. Here are what my shapes look like. One's long and skinny. One's more of a fatter, squattier shape, right? So they're all very different. Let's pop down to the very bottom question. Okay, we're going to skip the next box to do. And it's asking us again to compare the shapes with the least and the greatest perimeter. So which one has the least perimeter? It's this one. And this one has the greatest perimeter. What do you notice about those shapes? What do you notice about that? The one with the least perimeter, well, these partners are really close together, aren't they? Very similar. They're very close to the same length. Look at this one, though. This one is not. These numbers are very far apart. Long and skinny again. So when we write our answer to that, after we compare those with our eyes, okay, remember we're on number 11, so at the very bottom. These two are doing the same thing that we did at the top. So we're going to write down how we compared them. The rectangle with the least perimeter, and I'm just going to shorten that word. Perimeter, I skipped a letter there. Has sides that are close to the same length. So almost like a square, right? The rectangle with the greatest perimeter, right, is long and skinny. I know in math and in science we do a lot of writing. So if it's long and skinny, that means that those partners, right, are different. They're not similar at all. Okay? So if you need to pause to copy that down, you can do that. And remember, it's so important to take really good notes when we're doing our online lessons so that depending on the homework, you can look back in your math journal and you can use this and the other page or whatever pages we do together to guide you as you work on your homework, okay? Because I won't be there, right, to help you, and your parents probably aren't sitting here watching you. They might be, so they could help you. But your job is to take really good notes as we work on this math together, okay, so that you then can do this information or this independent work all on your own, all right? So remember, area is on the inside, and we multiply those adjacent sides. Perimeter is around the outside, right? And we add all those sides up. So the adjacent sides, and then we have to double that, all right? Have a great afternoon or a great morning.